Okay, so what if I told you that the very air you're breathing right now is tied to a chemical ghost, a poison that nearly wiped out all life, and our best clue for finding aliens? It's all part of the incredible story of oxygen. And today, we're going to unpack it. You might be thinking, how do those things even connect? Well, it's a story that stretches across centuries. We're going to start with a really simple question from way back in the 1700s. Why do things burn? And you'll see how the answer to that is now helping us scan the entire cosmos for life. So, to get to where we are now, to our modern understanding of chemistry, we actually have to start with an idea that was brilliant, super elegant, and totally, completely wrong. And it dominated science for a whole century. See, for ages, scientists thought that anything that could burn had this hidden fire-like element inside it. They called it phlogiston. The idea was when you set a log on fire, you weren't adding anything. No, you were just releasing the phlogiston that was trapped inside. And you know what? The phlogiston theory seemed to work perfectly. It explained so much. Like, think about this. You put a candle under a glass jar, right? It burns for a bit, then flickers out. Why? Well, according to the theory, it was simple. The air in the jar gets totally filled up, saturated with phlogiston from the flame. The candle literally can't release any more, so it just chokes on its own exhaust. Made perfect sense. So this theory was neat. It was tidy, and pretty much everyone believed it. But, and there's always a but in science, isn't there? As our tools got more precise, as we got better at measuring things, one single, stubborn fact popped up. A fact that threatened to bring the entire thing crashing down. And here it is. This is the problem that broke the whole theory. Burning wood, yeah, it gets later. That makes sense if it's losing phlogiston. But when you burn certain metals, a process they called calcining, they got heavier. Wait, what? How can something gain weight by losing a substance? It was impossible. It didn't add up. Okay, so that one single contradiction, the whole gaining weight thing, pushed chemists to look somewhere new. They started investigating the air itself. And across Europe, a few brilliant minds started closing in on the same answer. This strange, powerful, new gas. So in the 1770s, there was this quiet, kind of undeclared race happening. You had Carl Scheele over in Sweden who isolated what he called fire air. At pretty much the exact same time, Joseph Priestley in England finds the same gas. But it's this third guy, Antoine Lavoisier in France, who's about to take all these different pieces and finally put the puzzle together. Now Priestley, he was still stuck on the old theory. He's heating up this metallic compound, mercuric oxide, and he collects the gas that comes off. And this new air, wow, it was incredible. Candles burned with this crazy intensity. He put a mouse in a jar with it, and it lived way, way longer than in normal air. So, to Priestley, the answer seemed obvious. This must be air that's been stripped of all its phlogiston. It's dephlogisticated. Basically, it's super thirsty to soak up more phlogiston from the burning candle or the breathing mouse. And get this. He even tried it on himself. He breathed it in and said it felt vital, invigorating. He knew he was onto something huge, something really important for life itself, even if his theory for why it was all happening was about to get completely turned on its head. But, just discovering something isn't the same as truly understanding it. And it took the genius of one man to see not just a new kind of air, but a whole new way of thinking about chemistry. And that man was Antoine Lavoisier. See, while everyone else was busy discovering these new airs, Lavoisier was basically inventing a new science. He had this breakthrough realization. The mystery of burning wasn't about what was coming out of the fire, it was about what was going in. This just flipped the entire theory on its head. Where Priestley saw air that was empty of phlogiston, Lavoisier saw something totally different, an active, distinct element. He named it oxygen. So burning wasn't about releasing some ghost substance. No, it was about rapidly combining with oxygen. And that one insight, it explained everything. It even solved the mystery of the heavy metals. Of course they got heavier. They were gaining the weight of the oxygen they were bonding with. So by 1785, Lavoisier was done with it. He formally denounced the old theory. He even called phlogiston a veritable Proteus, like the shape-shifting Greek god, basically saying it was this vague, magical idea that people just changed to fit whatever they needed. It explained everything, which meant it explained nothing. He replaced that ghost with a real, measurable element. It's just so tragic. While Lavoisier is leading this incredible scientific revolution, a very different, very bloody political revolution is tearing France apart. And because he had worked as a tax collector for the old monarchy, he was a target. All of his monumental contributions to science, well, they couldn't save him from the guillotine during the Reign of Terror. But the story of oxygen, the element Lavoisier named, doesn't stop there, not by a long shot. Because oxygen has, well, it has a much darker side. We think of it as this pure, life-giving thing, but the reality is way more complex and, honestly, a lot more dangerous. Think about it. For the very first life on Earth, which was anaerobic, meaning it grew without oxygen, the rise of photosynthesis was an absolute catastrophe. The oxygen being pumped into the atmosphere was a toxic pollutant. It was actually the biggest global pollution event in the planet's history. For them, it was pure poison. And even today, we're living on a knife's edge. Our atmosphere is in this incredibly fragile Goldilocks zone for oxygen. If the levels drop just a little, below 17%, we'd suffocate. But if they creep up past 25%, the whole planet would be hit with uncontrollable wildfires. That 21% we have, it's a very, very finely tuned balance. You can see its destructive power everywhere. It's what turns iron into rust, it's what makes old paintings turn brown, and it's even happening inside your own body right now. Oxygen creates these destructive little things called free radicals that damage our cells and our DNA, contributing to aging. So let's be clear, we don't breathe oxygen because it's good for us. We breathe it because, over billions of years, life evolved these incredible defenses to manage this poison and harness its awesome power. Okay. So that brings us all the way back to our very first question. What on earth does an 18th century chemistry discovery have to do with searching for aliens? Well, the connection is all about chemistry. You see, oxygen is super reactive. It just doesn't want to hang around freely in an atmosphere. Give it enough time, geologic time, and it will always grab onto rocks and minerals and just get locked away. What that means is that a planet with lots of oxygen in its air is fundamentally unstable. It's a chemical system that is way, way out of balance. I mean, just look at our neighbors in the solar system. Venus and Mars, they're basically dead, chemically stable worlds. Their atmospheres are almost pure carbon dioxide. And then there's Earth, with its shocking 21% oxygen. It's a glaring, blinking anomaly. There is no known geological process, nothing to do with volcanoes or rocks that can keep oxygen levels that high. Only one thing we know of can do it: a living biosphere, constantly pumping it out. And that is why when our most powerful telescopes stare at planets light years away, this is one of the key chemical fingerprints they're looking for. If we find a planet with a ton of oxygen in its atmosphere, well, that's a potential biosignature. It's like a beacon shining across the vastness of space, telling us that planet might not be alone. And it's just such a profound legacy for a revolution in science that all started with a simple, simple question: why do things burn?